Welcome to our journey exploring the sun, the brilliant star at the center of our solar system. The sun is not just a source of light and warmth, it's the driving force behind life on Earth. In this video, we'll uncover the mysteries of the sun, from its immense power to its vital role in sustaining our planet. As we begin, imagine standing outside on a clear day, feeling the gentle warmth on your skin. That energy has traveled millions of kilometers to reach you. Let's dive into the fascinating world of our closest star and discover what makes the sun so extraordinary. Sun is a massive ball of hot plasma made up of several distinct layers. At its core, nuclear fusion reactions generate incredible amounts of energy, which then travels outward through the radiative and convective zones. The visible surface known as the photosphere is what we see shining in the sky. Above that, the chromosphere and corona form the sun's outer atmosphere, visible during solar eclipses. Each layer plays a unique role in the sun's behavior and appearance, contributing to the dynamic nature of our star. The heart of the sun, nuclear fusion, is the process that powers our star. Here, hydrogen atoms are fused together under immense pressure and temperature to form helium, releasing vast amounts of energy in the process. This energy radiates outward, eventually reaching Earth as sunlight. Fusion is what makes the sun shine so brightly and provides the heat necessary for life. Understanding this process helps us appreciate the incredible forces at work within the sun's core. Once energy is produced in the sun's core, it begins a long journey outward. First, it passes through the radiative zone, where energy moves slowly, taking thousands of years to reach the next layer. Then in the convective zone, hot plasma rises and cools, creating currents that transport energy to the surface. Finally, this energy escapes into space as sunlight, traveling across the solar system and reaching Earth in just over 8 minutes. Sunlight is essential for life on our planet. It provides the energy plants need for photosynthesis, which in turn supports the entire food chain. Sunlight also helps regulate our climate and weather patterns. Without the sun's warmth, Earth would be a frozen, lifeless world. Every living thing, from the smallest microbe to the largest animal, depends on the sun's energy to survive and thrive. Sun is not just a ball of hot gas, it also has a powerful magnetic field. This magnetic field is responsible for many of the sun's most dramatic phenomena, including sunspots, solar flares, and coronal mass ejections. These events can have significant effects on space weather, sometimes even disrupting communications and power systems here on Earth. The sun's magnetic field is constantly shifting and changing, making it a fascinating subject for scientists. Sunspots are dark, cooler areas on the sun's surface caused by intense magnetic activity. These spots often appear in groups and can last for days or even weeks. Sunspots are closely linked to periods of increased solar activity, such as solar flares and eruptions. Scientists study sunspots to better understand the sun's magnetic cycles and to predict space weather that might affect Earth. Solar flares are sudden, intense bursts of energy from the sun's surface. These eruptions release massive amounts of radiation and can sometimes be accompanied by coronal mass ejections, which send charged particles hurtling through space. When these particles reach Earth, they can create beautiful auroras but also disrupt satellites and power grids. Monitoring solar flares helps us prepare for their potential impacts. Sun goes through an 11-year cycle of activity known as the solar cycle. During this period, the number of sunspots and solar flares rises and falls. At the peak, called solar maximum, the sun is more active, while at solar minimum, activity decreases. Understanding the solar cycle helps scientists predict space weather and its effects on Earth's technology and climate. Sun's energy output affects Earth's climate in many ways. Changes in solar activity can influence weather patterns, temperatures, and even long-term climate trends. While the sun is not the only factor affecting our climate, its role is significant. Scientists study solar variations to better understand past climate changes and to predict future trends. Solar eclipse occurs when the moon passes between the Earth and the sun, temporarily blocking the sun's light. These rare events have fascinated people for centuries, offering a unique opportunity to observe the sun's outer atmosphere, the corona. Solar eclipses remind us of the intricate dance between celestial bodies and the wonders of our solar system. Corona is the sun's outermost layer, extending millions of kilometers into space. It is much hotter than the surface, reaching temperatures of several million degrees Celsius. The corona is visible during total solar eclipses as a glowing halo around the sun. Scientists are still studying why the corona is so hot and how it affects the solar wind. Sun constantly emits a stream of charged particles known as the solar wind. This wind travels throughout the solar system, interacting with planets and magnetic fields. On Earth, the solar wind can create stunning auroras near the poles and sometimes disrupt satellites and power systems. Studying the solar wind helps us understand the sun's influence far beyond our planet. When the solar wind interacts with Earth's magnetic field, it creates beautiful displays of light called auroras. These are most commonly seen near the poles and are known as the northern and southern lights. The colors and patterns of auroras are a direct result of the sun's energy reaching our atmosphere, creating one of nature's most spectacular shows. The tilt of Earth's axis and its orbit around the sun create the changing seasons. As our planet moves around the sun, different regions receive varying amounts of sunlight, leading to the cycle of spring, summer, autumn, and winter. The sun's position in the sky changes throughout the year, affecting day length and temperature. Every day, we witness the beauty of sunrise and sunset as the sun appears to rise and set on the horizon. These daily events are caused by Earth's rotation, giving us periods of daylight and darkness. Sunrises and sunsets are not only visually stunning but also mark the passage of time and the rhythm of life on Earth. Humans have learned to harness the sun's energy through solar technology. Solar panels convert sunlight into electricity, providing a clean and renewable source of power. Solar energy is becoming increasingly important as we seek sustainable solutions to meet our growing energy needs and reduce our impact on the environment. Throughout history, the sun has been revered by many cultures as a powerful symbol of life and divinity. Ancient civilizations built monuments, temples, and calendars aligned with the sun's movements. From the Egyptian sun god Ra to the Aztec sun stone, the sun's influence can be seen in art, mythology, and architecture around the world. Modern science uses advanced observatories to study the sun in detail. Telescopes on Earth and in space capture images and data across many wavelengths, revealing the sun's structure and activity. These observatories help scientists monitor solar storms, understand the sun's cycles, and protect our technology from space weather. Sun is about halfway through its life as a main sequence star. In about 5 billion years, it will exhaust its hydrogen fuel and expand into a red giant, eventually shedding its outer layers and leaving behind a white dwarf. This transformation will mark the end of the sun's current phase, but its legacy will continue in the elements it creates and the energy it has provided. The sun is located about 93 million miles or 150 million kilometers from Earth. This distance, known as an astronomical unit, is just right to provide the warmth and light necessary for life. If the sun were much closer or farther away, conditions on Earth would be drastically different. The sun is enormous, containing more than 99% of the total mass of the solar system. Its diameter is about 109 times that of Earth, and its gravity holds the planets in orbit. The sheer size and mass of the sun make it the dominant force in our solar neighborhood. Sun is primarily composed of hydrogen, which makes up about 74% of its mass, and helium, which accounts for about 24%. The remaining 2% consists of heavier elements like oxygen, carbon, and iron. This composition is typical for stars like our sun and is crucial for the process of nuclear fusion. Although the sun appears yellow from Earth, it actually emits all colors of visible light. When combined, these colors create white light. The atmosphere scatters shorter wavelengths, making the sun look yellow or red at sunrise and sunset. The sun's light is essential for vision and the growth of plants. The sun's immense gravity keeps the planets, asteroids, and comets in orbit around it. Without the sun's gravitational pull, the solar system would not exist as we know it. Gravity also shapes the sun itself, keeping its massive layers of gas bound together. The sun rotates on its axis, but not all parts rotate at the same speed. The equator spins faster than the poles, a phenomenon known as differential rotation. This rotation affects the sun's magnetic field and contributes to the formation of sunspots and solar activity. Our sun is about 4.6 billion years old. It formed from a giant cloud of gas and dust which collapsed under gravity to ignite nuclear fusion. The sun has been shining ever since, providing the energy needed for life to evolve on Earth. The sun was born from a nebula, a vast cloud of gas and dust in space. As gravity pulled the material together, the core became hot and dense enough for nuclear fusion to begin. This marked the start of the sun's life as a star, shining brightly in the cosmos. In the distant future, the sun will run out of hydrogen fuel and expand into a red giant. It will eventually shed its outer layers, leaving behind a dense core called a white dwarf. This process will take billions of years, but it's a natural part of a star's life cycle. Solar storms are powerful bursts of energy and particles from the sun. These storms can interact with Earth's magnetic field, causing geomagnetic storms that affect satellites, power grids, and communication systems. Scientists monitor solar storms to protect our technology and infrastructure. Light from the sun travels at an incredible speed of about 299,792 kilometers per second. It takes just over 8 minutes for sunlight to reach Earth. This means we always see the sun as it was 8 minutes ago, a fascinating reminder of the vast distances in space. Solar activity can have a big impact on our technology. Solar flares and storms can disrupt radio signals, GPS, and even power grids. Scientists work to predict these events and develop ways to protect our systems from solar interference. Plants use sunlight to convert carbon dioxide and water into food through photosynthesis. This process produces oxygen and forms the base of the food chain. Without the sun, plants could not grow and life on Earth would not exist as we know it. Sunlight helps our bodies produce vitamin D, which is essential for healthy bones and immune function. Spending time in the sun while taking care to avoid overexposure is important for our overall health and well-being. For centuries, people have used the sun to measure time. Sundials, calendars, and clocks are all based on the sun's movement across the sky. The concept of a day is defined by one rotation of Earth relative to the sun, making it a fundamental part of our daily lives. The sun's energy drives Earth's weather systems. It heats the atmosphere and oceans, creating winds, clouds, and storms. Without the sun, there would be no weather and our planet would be a cold, lifeless rock. The sun heats the surface of the oceans, causing water to evaporate and move. This energy drives ocean currents which help regulate Earth's climate and distribute heat around the globe. The sun's influence on the oceans is vital for maintaining a stable environment. Farmers rely on the sun to grow crops and raise animals. Sunlight provides the energy needed for plants to thrive, which in turn supports the entire agricultural system. The timing of planting and harvesting is closely tied to the sun's position in the sky. The sun has inspired countless works of art, music, and literature. It is a symbol of hope, renewal, and power in many cultures. Festivals and rituals celebrating the sun are found all over the world, reflecting its importance in human life. Innovations in solar power technology are making it easier and more affordable to harness the sun's energy. From solar panels on rooftops to large solar farms, these advancements are helping to create a cleaner, more sustainable future for everyone. Before modern technology, sailors and explorers used the sun to navigate the seas. By observing the sun's position, they could determine direction and latitude. The sun remains an important reference point for navigation even today. Solar sails are a new technology that uses the pressure of sunlight to propel spacecraft. By capturing the momentum of photons, solar sails can travel great distances without fuel. This innovative approach could revolutionize space exploration in the future. Artists have long been inspired by the sun's beauty and power. From ancient cave paintings to modern masterpieces, the sun appears in countless works of art. Its light and warmth evoke feelings of joy, hope, and inspiration. Space missions like NASA's Parker Solar Probe are helping us learn more about the sun than ever before. These missions collect data on the sun's atmosphere, magnetic field, and solar wind, deepening our understanding of our closest star. As we conclude our journey, it's clear that the sun is much more than a bright spot in the sky. It is the source of life, energy, and inspiration for our planet. From ancient myths to modern science, the sun's influence is everywhere. By understanding the sun, we gain a deeper appreciation for the interconnectedness of all life on Earth and the wonders of our universe.